Let's talk about heat really quickly. Heat is the spontaneous flow of thermal energy down a temperature gradient. So heat is what happens when you've got something hot and you've got something else that's cold, and they can interact somehow, right? And the hot thing loses thermal energy in the form of heat. So it has a negative heat action, and the cold body gains thermal energy through the process of heat, so it has a positive heat action, and the heat lost from the hot body must equal the heat gained by the cold body. Okay? We'll talk about the mechanisms of that and some of the governing formulas, but we won't really cover it until next year. Heat's not a property, so it's worth knowing that. So this is a path variable, is what it's called. So, for example, in a closed cycle, Q net, U, the cyclic integral of U equals 0. Whatever gains U took as it went round, it lost. It had a gain, it had a loss, so that when it got back to the start, it was 0. The cyclic integral was 0. The cyclic integral of Q was not 0. You had a Q net at the end of the process. You had a W net at the end of the process. So it's not a property of the system, and we'll see it represented in kilojoules in its extensive form. We'll see it in kilojoules per kilogram in its specific form, and we'll see it on a rate basis. So you're adding, and you're familiar with that, kilowatt. You might be adding 150 kilowatt of energy. Actually, you're adding about 140 watt of energy to the room at the moment. If you're sleepier, it goes more towards 100. If there's no heat transfer, we call that adiabatic. In real terms, if you've got a temperature difference between bodies, you always have heat transfer, but we can either insulate things really well, okay, using things like foam, polystyrofoam. That's a great material up to about 100, 110 degrees, then it starts to melt. Asbestos is a really great material for thermal insulation and not for your health. We don't use asbestos anymore. But I'll show you a table yes. So you can use good materials. Metals are typically very conductive, ceramics less so. If we do a process fast, or we insulate it, then we can pretend like it's adiabatic. And it lets us simplify things. We can take a whole term out of our equation, and that's useful. Sign convention, we've talked about. Heat in is positive, heat out is negative. Quick treatment of heat. Q. Once again, we don't use H. H is reserved for something else.